we are going to discuss a concept about NumPy. So what is NumPy? NumPy, that is nothing but a numerical Python. So why this numerical Python is used? The main object of numerical Python, which is used to get the multi-dimensional homogeneous array. So we are just going to today create multi-dimensional arrays. So why we are just handling this array? What's the purpose of this? So we are just going to handle a table of element, usually the numbers, maybe the different type of data types, maybe the same data type, and we are just going to index a tuple, non-negative integers, and we are just going to handle the NumPy dimension in your images. So the NumPy images which mainly used to applicable in the image analytics. So now we are going to handle array oriented computing, and then efficiently we are going to implement a multi-dimensional array, and this NumPy which is mainly designed in scientific computation, and the NumPy is a very convenient to work with in matrix multiplication and reshaping a method, and your NumPy array which is supporting the broadcasting. The main usage of NumPy is it's applicable in your finance Python, like a linear algebra. All those things are very easy when we are handling with NumPy. So now let's we start to handle our NumPy. So how to handle this NumPy? So to deal with NumPy, first we need to import the NumPy. So I am just importing import NumPy as NP. So this is nothing but I am just importing a NumPy in the name of NP. That's what the meaning is. So now we imported the NumPy. Great. So now we need to create an array. So let me create a list. So I'm just creating this list. Great. So now I am just giving print my underscore list. Okay, we got the answer. So now this is one dimensional array. That is what our list data type. But by using a list data type, we can able to handle our append, index, extend, all those things. But simply we can't able to create a multi-dimension array. So now we are handling a NumPy which is mainly used to create your multi-dimension array. So I am just going to create a variable name called my matrix. So now I am going to give a multiple list here. So 1, 2, 3, I am just considering this as a one list. Then 4, 5, 6, this is considered as another list. Then we are just going to create 7, 8, 9. This is considering as another list. So let me execute this my matrix. So we got an output like this. But now we want to make this in an array format. So how to create an array? So NumPy, that is nothing but our numerical Python dot array. It's a inbuilt function. So in the argument I am just giving my variable name as an argument. Great. Now we created an array. So what next we can able to do is I am just giving a NumPy dot array. So now inside this I can able to create some array like this, comma, and 4, 5, 6. Great. We can able to create a NumPy array. So again I am just giving x is equal to NumPy dot array. So now I am just giving a print of x. We got the output. Great. So the next thing which we are going to handle, that is nothing but a built-in methods in your NumPy array. So what are known as a built-in methods? That is nothing but a range, or to get the random values from the NumPy, or to fill one matrix with the different elements. So now we are going to handle inbuilt functions, that's nothing but a built-in methods of our array. So now I want to create a full of a range. The range may be from 0 to 10. So now what I am just going to do is NumPy dot arrange. I am just giving 0, 10, from 0 to 10. So we got this. Now the same range I want to print by some steps. That's nothing but for only 2 steps or 3 steps I want to print. So I am just giving a 2. So from 0 to 11. So 11 excludes, we will print till 10. So 2 values 0 1, 0 gets print, 2 3, 3 gets print. So now here we used to get only our even numbers. Great. So now I want to create an array which is full of zeros. So NumPy dot zeros, what I am just going to create is 5 comma 5. That is nothing but I am just going to create 5 row 5 column full of zeros. So for this we need to give an array like this. Yeah, so now 5 row 5 columns which is filled with only zeros. Great. Then now I am just going to deal with NumPy dot ones. So now the same 5 row 5 column which is full of 1. So 5 row 5 column. So always in the NumPy we used to get row comma column. So this is how your NumPy will work. So when we are executing NumPy 5 comma 5, NumPy dot ones 5 comma 5 or NumPy dot zeros 5 comma 5, it's nothing but a row comma column. So always is used to execute row comma column. So the next thing what we are just going to deal with, that is nothing but full. So the variable name NumPy dot full. Now I am just going to fill 3 comma 4 comma 5. So now what it will do is 3 comma 4, that is nothing but a row comma column. So now we are going to create a 3 row 4 columns which is going to fill with 5. So now we'll give print of x. Great. So 3 row 4 column which is filled with 5. So instead of 5 we can able to give any numbers. So I am just giving a 15. So we used to get the 15. Great. So this is what full ones zeros. So apart from, we are having something else that is known as a line space. So what is this line space? That's nothing but which is used to return your numbers eventually spaced. That's nothing but when you are giving 0 to 10 and 3, now it will give 3 numbers from 0 to 10 which is having the same different length. So let's see the example. So now NumPy dot line space, it's an inbuilt function. So I want to print 0 to 10 for the 3 elements. I want to get 3 elements from 0 to 10. So 0, 5, 10. So from 0 to 5 we have 5 difference and 5 to 10 again we have the 5 difference. That's what your line space is. Great. So the next thing is I am just going to create the diagonal. So what is diagonal? In the slope, like in the line like this, we used to get one line. So for example, this is one diagonal. So we used to get 1 0 0. So again here 1, the remaining everything will be 0. Then again here we will get 1, so remaining everything will be 0. So we used to get the same line of slope. That's what your I is. That's what our diagonal is. So diagonal which is used to create a diagonal slope. So NumPy dot I, that is an inbuilt function. Now I am giving a 3. That is nothing but 3 row 3 column. When you are just giving a 3, it will consider only row. It won't consider column. So it will automatically give 3 row 3 column. Let's we give 4. So 3 row 4 columns. Still we get the diagonal. So if I am giving a 4 row 4 column, so your output will comes like this. Now I want to print the random element of from my NumPy. So I am just giving NumPy dot random. Yeah. So now this NumPy dot random from NumPy I am getting this random package. So from this package I am getting this built-in function. So this is actually the built-in function. NumPy dot random is nothing but the complete built-in function. So I am just giving a 2. So let me execute. So we are having this. So now we have a 2 arrays of our NumPy. So now instead of if I am giving a 5 comma 5, so now in the random element I will get 5 row 5 columns. This is what NumPy dot random is. So here everything which we are getting it is an float. Now I want to get only integer. So NumPy dot random name. So now I am just giving 1 to 100. So now I will get, still we are getting in a float because I gave random. I am just giving an integer. Let we give, yeah. Okay, so we are getting the error of, yeah, it has no attribute of RANINT. So attribute error, that is nothing but the particular framework which is not contains the built-in function. So numpy.random which not contain RANINT built-in function. So that's nothing but RAND. So 14. Now from 1 to 100 you are actually getting any one element as a random. Again I am executing 20. So again 58. So again 57. So again 38. So each and every time you will get a different random element. Now you want to get 5 random element from as an integer. So now you got a 5 random element in the integer method. Great. So now we created a random array. The next thing is which we need to go ahead with indexing slicing in your matrix. Yes. So our next concept is indexing and slicing. It's nothing but a very important concept. So when you are just creating a my matrix which is having a value like this. So let me going to create my matrix. Sorry, we need to give numpy.array, np.array my matrix. Okay, now I am just giving a print of x. We got the output. So now row, column. Now always whatever itself in your numpy we need to call row comma column. So whatever you are given in the first value which will consider as a row, and whatever you are given in the second value which always consider as a column. So now we are going to apply our normal indexing method for our row and column. So how to do that? So now x is equal to, okay, there is no need of assigning to any variable name. So let's we go like this. So now what I am just going to do is 0 to 2. So now this is actually for your normal indexing slicing method. So from 0 to 2, it will start from 0. Always the last value got excludes. So 0, 1. So 0, 1. We are getting the full row of 0 and 1. This is what actually slicing in your array. No, we are just getting the row, but still it will consider as a slicing. But I want to get index location. I want to point out any one thing that we need to give it row, comma, column. So for example, now I am giving 0. So now x of 0, I will get the complete 0th row. So 0th row is 1, 2, 3. But now I am just going to give x 0, 1. So 0th row, first column. Whenever you are using comma, row, column. So 0th row, first column. So 0th row is 1, 2, 3 and the first column is 2. So we are getting the output of 0th row, first column. Great. So this is what your row and your indexing by using your row and column. Great. So now I am going to apply another thing. That is nothing but x 0, only the 0. So you will be getting the full row. So I am just giving 0 to 3. So now it will get 0, 1, 2. So anyhow you are having 0, 1 and 2 like this. Great. This is row always, comma, column I am giving 1, colon. So now from 1 till end. When we are giving 1 colon, till it will go for the end of the column. That's what 1 colon. So 0 to 3, 3 values excludes. So it will consider 0, 1, 2. So all the rows which is getting considering in this method. So 1 colon. So 1 colon means 1 from the first column till end. If we given 3 value excludes. I am simply giving this. So now my output will be 2, 3, 5, 6, 8, 9 like this. Great. Now I want to get 1 to 3 comma 1 colon. So now here, hope you understand this 1 colon, that is nothing but from 1 to till end. So 0 to 3, it will consider 0 to 3 value excludes. Now 1 to 3, the third value excludes. So here our output will be 1 and 2. So 1 and 2 row and 1 till end the columns. So now our output will be 5, 6, 8, 9. This is our output is. Great. So now when I am just giving all rows, comma, I am just giving 1. So it will consider all the rows and the first column. So here the column value is 2, 5, 8. This is our first column. So all rows, it will consider your first column. Now the same thing I am just giving all rows 1, 2, 3. So now 1 and 2 column getting considered. So when it comes to 2, 5, 8, 3, 6, 9. So we are getting this. So when we are just using this, it will consider all the rows, comma the column. So it will give only this particular column. Okay. So this is how our indexing and slicing will work in your NumPy. So our next thing is, we are just going to discuss about reshaping an array. So what is reshape? So let's create one range array. So for example, I am just going to create ARR NumPy dot a range of 25. So now it will give 0 to 25 the values in ARR. So now I am going to create one more variable name RANRR NumPy dot random integer. So now I am going to create an integer value of 0 to 50 for 10 elements. So now when I am printing ARR, you will get 0 to 25, and when I am just printing RANARR, so we will be getting 10 elements in between to 50, 0 to 50. Great. So now this is our exactly, we have a 2 elements. So this may be 0 to 25, 25, and this is a 10. So now we have 25 characters with your array. So now I want to reshape this. So instead of having in the single line, I want to make this 5 into 5 matrix. So for that perspective, what I am just going to do is variable name reshape 5, 5. So 5 rows, 5 columns. Great. So 0, 1, 2, 3 like this. It is starting from here and just ending here. So all those things which will be getting within this 5 row, 5 column. Great. So now we are having another variable name RANARR. So now I want to get the maximum value of this array. So array max. So now it will give the maximum value of this particular array 40. So 40 is the maximum array of this thing. So again what I am just going to do is the same, I want to get the minimum value of this array. It's a 40. Great. So now 40 is the maximum value in this variable name, and 14 is the minimum value which is in this variable name. Now I want to get my index position of the maximum value and the index position of my minimum value. So now I am just giving RANNAR dot argument max. So now I will get the index position of my max. So 40, 0, 1, 2. So in second index we are having 40. So that's what my maximum value index position. So and then ARG minimum. So this is what my maximum value index position is. 14 is in first index and 40 is in second index. So this is what our maximum, minimum, argument maximum and argument minimum. So now we are going ahead with the another concept, that is nothing but a shape. So what is shape? Shape is nothing but one of an attribute in your array where we have a vectors which is going to give only one column. Vector is always be in the only one direction. So now I am just going to handle the vector array. ARR is a vector array. So I am just giving a shape. So now we have only 25 rows. We doesn't have any column in ARR. Here we just apply the reshape, but we didn't save this thing to any variable name. So this is for only temporary execution. So when you are just choosing this ARR, here it's you are having only 25 rows. You don't have any columns. So when I am just giving ARR.shape, you are just getting only 25 comma. That's nothing but it's only make 25 rows. Great. So now what I am just going to make is I am going to apply the reshape. So reshape, that's like here we just make a 5 row 5 column. So again I am just making reshape. There we make 5 row 5 column. Here I am just going to make 1 row 25 column. See, if you notice that it will comes with 2 set of brackets. So that is nothing but it may be considered as a 1 row 25 columns, but still your output it's not comes like this. It's like 1 row 25 column. Okay, great. Now what we are just going to do is, now I am just going to check the shape of this. So now dot shape. Yeah, 1 row 25 column. Here you got 25 comma. It's nothing is there, so we are getting simply 25. But here we are getting 1 row 25 column. That is nothing but it's having only 1 row and it's having almost 25 columns. Now I want to reshape with 25 column 1 row. Sorry, 25 row 1 column. Is it possible? Yes, this is actually possible in our NumPy. So now I am just going to make 25 comma 1. See, here we are getting a 25 row and only 1 column. So now I want to check the shape of 25 row comma 1 column. Yeah, row is 25 and the column is 1. Great. So now this is reshape, which is mainly used to reshape your array based on your convenient. You can able to make 1 row multiple columns or multiple row 1 column. This is nothing but your vector arrays. So now we are going to discuss about the very important concept, that is nothing but broadcasting. So what is this broadcasting? So why it is used in NumPy? So this broadcasting is nothing but one of the NumPy concept which is used to refer the ability of NumPy to treat your arrays of different shapes of arrays which is going to perform the arithmetic operations. Even we can able to perform the arithmetic operations on arrays which is having the different kind of dimensions. So if you have a 2 array exactly which is in the same shape, it's fine to do your arithmetic function. But when you are having a 2 array which is exactly in the different shape, dealing with your arithmetic function is little difficult. Now this broadcasting method which is actually help us to make our broadcasting method more easier. The first thing is they are equal or one of them is 1. Like this we should make. If they are not equal and if it's not contains any one of them is not equal to each other, we will get a value error. See, broadcasting is mainly used to make different shape of arrays to do arithmetic functions. That's what actually your broadcasting is. Now I am telling you, even for all the situations it won't apply. Some situations we will get a value error. Let's see in which of the situations we used to get the value error. So before that we need to start with creating an array. So a equal to numpy dot array. So what I am just going to give is 1.0, 2.0 and 3.0. So this is what your numpy array is. Now I am just giving b is equal to 2.0. Then the next thing is c equal to, I am just giving a plus b print of c. So now we have only one array in NumPy. So your output will be kind of one dimensional list. So when you are just giving a plus b or a into b, whatever itself, it will go and added with your a. So 2.0 go and added with 1.0. So again your 2.0 go and added with 2.0. So your 2.0 go and added with your 3.0. So your output will comes like 3, 4, 5. So now how it's working is, when we are having an one array like this, like maybe 1, 2, 3. This is one value and this is another value and this is another value. Now we have only one value, that is nothing but a b. Now this b go to this first index and to the second index and to the third index. So this scenario will work out here. So the next thing is, now I am just going to make some modifications. Okay, so let's we go with creating another variable name numpy dot a range of, I am just giving a 4. Now I am creating a 4 data is nothing but in the same range. Now I want to reshape it. So another variable name x dot reshape. You know like what is reshape is? Now what I am just going to reshape is 4 comma 1. So 4 row 1 column we created. Great. So now y equal to numpy dot ones. So I am just creating a 5. Then what we are just going to create is z is equal to numpy dot zeros 3 comma 4. So the next thing is, now I want to check the shape of xx. So we know it's a 4 row 1 column, so we'll get a 4. And even shape of y dot shape, y dot shape 5 and my x dot shape is 4. So now when I am planning to add x plus y, I am getting a value error. This is what I told. They are equal in size, else any of one should be 1. So in this scenario, here we have a multi arrays like 1, 2, 3, but b which is having only one value. But when it comes to this example, our second example, what we are having is an y. So y which is mainly having 5 and x which is having 4. So now we have a 1, 2, 3 and then we have a 4 and then we are having a 5. And then even in y we are having everything as a ones. So 1, 1, 1, 1. So now this one will go everywhere maybe, and this will go, but this will go and this also go. So we don't have a equal dimension. So it don't know like the output should be in 4-dimensional or 5-dimensional. So we are getting the value error. So when we are planning to broadcast, at least it should be in the same one array, multiple arrays. Else both the variables should be in the same shape. Then only we will get the smooth answer. So for example, now we having an xx. So let's me print xx and I am just printing an y. So now we have a value like this. So here we have a 5 and here also we having an almost 4. So now when I am just planning to make this, what I am just going to do is xx plus y. So now how it's working? So now we have 5 rows and 4 columns. So now we get a 5 rows. So all these things will be 1 in the 0th row. The reason is the first column value 0. So now this 0, so let me just explain here. So we having actually 2 values. One is 0, 1, 2 and then 3. The next one is we are having 1, 1, 1, 1, 1. So where now we have actually 5 column, 4 rows. So we have 4 rows and we are having actually 5 columns. So now this 0 with all this 1. So our first value will be 1, 1, 1, 1. And then this one with all these rows. So now 2, 2, 2, 2, 2. Like the same, this 2 with all your 1, so everything will be your 3. And this 3 with all your 1, so everything will becomes a 4. So now end of the result will be getting like this. This is what broadcasting is. Even if you want to do for the different shape, it's possible, but it should be in the equivalent. So we can able to apply this x and y, but we can't able to apply our x and y. This is what actually our broadcasting is. The next thing is we can able to apply our conditional statements with our NumPy array. So what I'm just going to create is another variable name called x. So I'm just going to create a NumPy a range of 1, 11. Great, I created just giving an x. So now I am just telling x is greater than 4. So here which values are greater than 4, I will get true. Which values are less than 4, I will get 3. So here everything we will be getting in our boolean value. Great. Now I am just making one more variable name like bol. So it may be give some built-in function boll. So I am just giving a boolean array. So now arr will go for the x itself. So bool array, that's nothing but our boolean array. Okay, so we are just getting boolean underscore arr is not defined. Okay, I just assigned this but I didn't execute, that's the reason. Yeah, so now which values we get here as a true, those values are now we are getting in our indexing position. So this is another way to create and handle your functions. So apart from we can able to handle arithmetic functions between two arrays, and even we can able to handle universal array function with our arrays. So for example, now I want to create an array. So it may be in a range of something. So here we have a x, it's having a range. So now I am just going to apply my square root. So numpy dot square root of, I am just giving x. So for each and every elements in our x, it's applied with your square root. And even we can able to apply our exponential if you want. So exp is the exponential short form, and I am just giving x. So now what we can able to do is we can give x plus x, we can give x minus x, but still it will give some weird answer, and then we can give x into x. This is all our arithmetic functions which can be able to apply with our numpy. So by using numpy, even we can apply the logarithmic, sine, tan, all those datas. We can able to apply any functions with our numpy, and we can able to deal with any matrix, multiplication, addition, division. Even we can able to apply the broadcasting by our numpy, but the broadcasting it should satisfy some of the rules. So it should be in the same shape, else it should be in the one should be in n number of space and another should be in only one value. Like this we can able to handle our broadcasting. So these are the basics of NumPy. See you in next session.